I'm David Bood. Joining Maz and Nikolai Durkov. They will be helping answer questions. Today we're going to be talking about ECAD MCAD collaboration with the Altium CoDesigner. So let's get started. First, we're going to talk about why you need to start doing co-design, start practicing co-design. Then we're going to go into a little bit about what co-design actually is, some of the options we have had in the past historically, some of the issues with those options, why you should use Altium CoDesigner, what some of the benefits it can provide for you. Then we're going to go into PTC Creo and actually use the Altium CoDesigner in Creo and Altium Designer 20 and make a project going back and forth. Then we're going to go into a Q&A section. So if you have any questions throughout the webinar, please put them in the Q&A section. If you see any issues, put it in the chat section. However, the Q&A section is the best area for us to interact with each other. But like I said, if you have issues, the chat section is better. Throughout this, there will be polls being initiated so we can better serve you with the tools. So we will be asking certain questions, and Matt will be initiating those poll questions throughout this webinar. And you'll see them just kind of pop up on your screen and you can answer them and they'll go away. So let's start off by talking about what co-design is, right? When we start talking about designing, right, a product itself is the combination of both the mechanical and electrical design. And when we start thinking about a product, we're not just designing the individual PCBs, we're designing devices, right? This here is a drone example that is included with every installation of Concord Pro. As soon as you install Concord Pro and you look at the sample data, you're able to look at this multi-board design. And you could see that this was not created by just thinking about individual PCBs. This is a product, okay? This was made together in the context of each board, right? You have to think of how everything is laid out. These boards are very dense. We're gonna go into it in Creo and actually look at the board, the product overall, and see how dense these layouts actually are, right? When you start looking at this, you see how incredibly packed these things are. And you see the role that everyone has to play. You look at the mechanical engineers and you see that the mechanical engineer has to define, they have to define the requirements of the PCB in the context of the device. They often give you the geometry, mounting holes, a key placement of things such as the connectors, keep out areas, right? If you have a connector in an area that's not allowed, they need to define that. Otherwise, how is the electrical engineer going to know that? It's quite possible that in the context of the single PCB, that component can very well be in that area, but in the context of the entire product, that connector cannot stay in that area. And we're going to look at that a little bit more when we start making this, this board in the demonstration. Then when we look at the electrical engineer's role, we need to see how they define precise 3D models for the PCB. So they're defining the components, the copper, and the silk screen of these individual boards. But it's really important that they collaborate on these changes and that they're doing this quickly and they're going back and forth. And if these changes are not communicated clearly and quickly, you have a huge problem. So now that we've kind of talked about the needs of co-design, we start looking at the ways that people have done co-design in the past. So in the past, a lot of people came from the mechanical side over to the electrical side. They used DXF and step files. This was okay. It allows you to automate the creation of the board outline. Big problem here is that the board shape needs to be handled manually. There's issues with gaps in the board outline. Again, this needs to be handled manually. A huge issue that you'll see here for both sides, I guess I'll wait to talk about this, but let's go to the next step. From the electrical engineer to the mechanical engineer, they often use step models. And this allowed you to have 3D models of the board assembly. This was very useful, but there's very low performance often in a lot of the tools. Getting the step file over to the MCAD side. There's generally over definition of the step model itself in the electrical space over to the mechanical space. There's too many definitions of the faces, and it kind of overwhelmed the mechanical tool. So there's a redundant assembly structure, and there all of the components in the assembly were defined individually. Let's see, on top of that, there's just a lot of duplication in all of the definitions of these things. One of the things I was going to mention earlier was that both of these requirements, it's manual, it's something that you have to do over and over again on both sides, right? It requires generation that you need to do, like I said, over and over again. And it just takes time that you don't need to be spending, right? And again, there's more issues, but we don't really have to go into too many details. I'm sure a lot of you have gone through these issues yourself and have felt the pains. So coming through some more, there are some advanced file formats. There's IDF, IDX, and this is just a little bit better definition of the assemblies themselves. I see some questions coming in. Thank you. Hey, Matt, can you initiate the first poll over here? Thank you. So Matt's gonna initiate the first one. Just what is your role in your company team, right? So we talked about your what is required on the mechanical side and on the electrical side. So we kind of want to know, you know, who's joining this webinar? What are your needs? So looking on the advanced file formats, you still have the same type of issues. It's complicated in terms of the prep for the export and import. And again, if you're doing these things repeatedly, you don't want something that's complicated to set up, right? And again, you don't want something that has manual file exchange. Sending these files over, it's just a complicated process, and you could quite easily send the wrong version, and no one wants to do that. So the last option we have the Altium CoDesigner. This is going to enable bi-directional collaboration between both engineers, right? And this is going to be directly in both of the tools, both the mechanical tool and Altium Designer, right? And this will display changes. It allows you to track changes. It gives you the author of the change, a timestamp, and it gives you a lot more information. It gives you true copper geometry that allows you to have models for analysis as well. That's something that you are not able to have in any of the other exchange formats. So let's go a little bit deeper into that. So what exactly is the Altium CoDesigner? So it's an application for exchanging PCB data between both the electrical and mechanical side without the manual operation of the files. So we talked about all the different file formats, DXF, IDF, IDX, yada, yada. I mean, there's a lot of different file formats. I'm sure a lot of you have been working with them for years. You don't need any of those file formats anymore. You don't need to render them. You don't need to create them. You don't need to import, export anything. You just use the application. And these applications are built in directly into both of the tools. And like I said, Altium Designer and the mechanical tools. So in Altium Designer, it's built in as a panel. If you use Altium Designer, you're familiar with panels. If you are on the mechanical side, using these MCAD tools, it's a plugin that just installs on top of it. It just kind of, you'll see right now when we use it in Creo. So it allows you to work with native design files in both of the tools. So it actually translates the design data into whatever tool you're using. So if you are using Altium Designer, it's using the Altium Designer tool, format, design data format. And if you're using whichever MCAD tool, it's using those native file formats. And this supports on Concord Pro, whether it is hosted on premises or whether it's hosted on Altium 365. Today, we're going to be working on Concord Pro on Altium 365, which is our cloud platform. And of course, it also works with Altium Nexus. And currently, the support exists for SolidWorks, PTC Creo, and Autodesk Inventor. And this is the current support as of January 2020. I guess I should put February 2020. I had made the slides earlier, so I guess as of February 2020, those are the current supported. Currently, PTC Creo and Autodesk Inventor do not need any additional licensing to have that interaction. Our partnership with SolidWorks requires an additional purchase of the PCB connector license. Depending on who you're working with, some of the resellers are a little bit confused on that, but it is the PCB connector license, not the MCAD CoDesigner license, which is another separate product that is its own standalone thing. So don't get confused on that. It's the PCB connector, and it will help you. That's all you need to enable this functionality. So let's go a little bit deeper into what Altium CoDesigner can help you accomplish. It's going to help you set up the initial board geometry. When we talk about the board geometry, we're talking about the entire board outline. We're talking about holes, cutouts in the mechanical space. Good, we're getting some more questions. That's good. Board cutouts, and all of this in relation to our actual enclosure, right? And then we're going to be able to transfer all of this into Altium Designer. Then after that, we're going to place all our mechatronic components, all of our key connectors, LEDs in the mechanical space, and then you can actually recognize this in the ECAD tool, right, in Altium Designer. This is currently supported in PTC Creo. We're working on having it supported in SolidWorks and Inventor, but it's really cool to place the models in Creo, and then it pulls the information from Concord Pro, and we'll go into more detail about that. So don't worry about the logistics of that right now. I'll talk about that in a little bit more detail later. So from there, once you're in the ECAD space, you're actually able to transfer all of the copper geometries over, either as a picture or as extruded bodies if you want to run some simulation, if you actually want to be able to click and grab onto any of the copper features inside the mechanical tool. Following up on that, silk screen as well. You know, it comes over as a picture, as a decal in the terminology of the MCAD space. From there, you could transfer the changes back and forth, board geometry, component placement, anything of the sort, and you can accept and reject any of the changes on both sides from the ECAD and the MCAD side. And as I mentioned earlier, you have a record of authoring, comments, any changes, and you have some nice timestamps. Okay, so some of the advantages of using the CoDesigner. It works much faster than the file export because this is only doing essentially a delta change for your design. So if you only move one component, you don't have to re-render your entire board. It's just going to pass over the information of that movement, right? It's not going to have, you're not going to have to re-render your whole board. It knows the changes that have been applied to your board, and it's going to pass that over, and that's all that you're going to have to deal with, right? It simplifies collaboration too. The changes of it, because you can track the changes and comments for those changes as well. So you know what the changes are, you can view what the changes are, you can accept or reject the changes, and you have a history of those changes. The models being exchanged from both sides are converted through the system in parasolid format, which is much faster than the other exchange formats. And that's something you don't have to think about. It does that automatically. And again, it converts it to the native file formats of the ECAD or MCAD system. And in general, it allows you to focus on your practical needs instead of solving IT issues, right? Instead of solving how do I need to communicate these things back and forth, how do I need to set everything up, it just, you know, works. You just push and pull and everything is ready to go. I see some more question and answer coming through. So before we start the demo, I'm going to say let's initiate the second poll question. So the second poll question, I'm going to do the second and third poll questions first. The second and third are very related to each other. So the second question is, how do mechanical engineers send PCB data to electrical engineers at your company? And the third question is the opposite. How do electrical engineers send PCB data to mechanical engineers at your company? So I'll start that, and while I get started, eventually Matt will end that and initiate the third poll. Okay, so we're gonna start off by coming over. I realize my mic is right in the middle of my screen. It's gonna make it difficult. So I might have to change my share. Okay, can everyone see Creo? Some hand raises. Okay, okay. So we have this drone. As I mentioned, this drone is included in the sample data for Concord Pro. So everyone can actually take a look at this when you either install Concord Pro, or if you are using Concord Pro on 365, we create a workspace for you, and within a matter of minutes, you can log in and get started, and you have the sample data, right? Okay, so we have the multiple boards here, and what I'm going to do is actually hide this board and this enclosure. So the board we're going to look at today is we're going to look at creating the basic board outline and the key placement of the key components of this board right here. You see it needs to be mounted onto here, so we're going to make some holes. That's going to be the basic thing we're going to do today, and we're going to do that from scratch. So to get started, I'm actually going to close that out. To make things a little bit easier, I'm going to remove those from my history. So you see here we have the enclosure itself. If I come back to Altium Designer, you see this is what the board looks like when it's completed. Again, this is in the sample data. Since I want to show the creation of it, Matt, can you start the third poll, please? Since I want to show the creation of it, what I've done is I've created a new sheet here, a new project, right? With just 3 of the key connectors, right? So we have 3 key connectors here. And I'm going to do new PCB. And one of the great things here is since I'm using Concord Pro, I have a template created for all of my projects. And since I have that, it will create a new PCB with a layer stack that is already defined, and it will have certain parameters already defined to suit my company needs. So that's one of the great added benefits of Concord Pro as a whole. So now that we have that done, I come over to the MCAD CoDesigner panel. You can go to Panels, MCAD CoDesigner if you don't have it up already. And I am just going to do push. If I do push and share, I can specify like someone's email that I want to share that design to. But I don't want to send it to anyone, so I'm just going to say initial push. And I'm going to post this. I, of course, have to save it for the first time. And I see it push. I come over. We have the Altium CoDesigner panel in Creo. So I can pull board from server, and I have my MCAD CoDesign, right? I pull in project assembly. And if you have PTC, if you have Windchill, we have integration with that PLM system. We have integration with a couple other PLM systems. I don't have it set up, so I just want to mention that if that's something that's important to you, but you would be able to have that all set up here. So I'm going to check out, and you see that it's going to pull in the board, the entire shape of the board in just a matter of seconds. And you see there, I didn't have to render anything. I didn't have to send anything. All I did was pull, and I have the board here ready to go. So what I'm going to do is I'm going to go to this full assembly because it's important to, we're designing in the context of a product, right? So I'm coming here in the context of the full product, coming in session, and I'm going to pull in this assembly. I'm going to make it coincident to this enclosure, and I'm going to place it in here. So now that I've done that, I am going to reorient it to make this a little bit easier, right? With the board outline. And I modify the board outline shape. So the easiest thing to do here is actually, I am going to delete the entirety of my board outline, and I'm going to set it to loop. You see right here, I can actually just do an offset of this shape, and right there, I have perfectly created a shape for my board. From here, I need to create some holes to align with the mounting holes. So I'm going to put these here. I'm going to do 0.12. This one as well, 0.12. And I want a radius of 0.1. So this is very important right here, okay? So this depth needs to be drilled up to next surface in order to properly be recognized by Altium Designer and come through the Altium CoDesigner panel. And I had another one over here. So I'm going to do the same thing. Perfect. Let me make sure that's on the board edge. Okay. And there we have it. So now we've created the board outline and the mounting holes rather quickly. From here, I am going to do the initial placement. So I mentioned that in Creo, we have added the ability to do the initial component placement on the mechanical side. So I'm gonna place this over here, and then this is key right here. I'm going to use a distance constraint, but I'm only going to use it for placement. The reason this is key is because I have not fully constrained my board to the enclosure. So because I haven't done that, it can cause unpredictable behavior to add additional constraints for distance. And it's bad practice to do that on the mechanical realm. So I saw from the poll earlier, a lot of you are electrical engineers. So I would just want to let you all know that that's bad practice. So I use that constraint for placement only, and I deleted it. Okay, so from here, right, I'm going to hide this face, and I'm going to add some more components. I have DF40 now. And when you are constraining, I think I mentioned this, but just in case, it's nice, you do the flat side right there. And this one's actually going to be on the opposite side of the board over here. And we're going to do something very similar. Placement, new constraint. Once again, distance. Here and here. We're going to do negative 0.1. Once again, but again, deleting it, but keeping the coincident constraint so that it remains flat on our board. And then the last component we are going to place, the last key component, is this connector. And I click here. One more coincident constraint. From there to here. Did that. Okay, place correctly. There we go. Okay, and then distance from this edge over here, negative 0.1. And there we go. So we have the basic placements. Let's do the orientation again. So now we're going to go back. This is the product view, product assembly. We go down to the individual board and we see that it automatically updates, right? From here, what we're going to do is currently there is a limitation where if there is a reference between the individual board and the external enclosure, that needs to be removed. So simply go to edit the board outline, remove the external references, just go to edit, okay, and you're good to go. We're working on making that more intelligent, so we don't have those issues, but for now you have to remove those external references. So now that that is done, I come back, CoDesigner, I do push, I say initial board outline, key component, this keyboard is so small, placements, and whole creation. Okay, initial board outline, key component placement, and whole creation. Perfect. So post, and it posted that, and I can switch over to Altium Designer, and I see automatically, oh look, there's some changes. So I can see the changes, and I can view them individually, but I'm going to select them all. And you see I actually have a preview of all of the changes. So I'm going to apply the changes. Oh, but look, there's actually an issue here. There's a collision. So I'm just gonna move this over. Okay, that looks good. These holes, I'm gonna make these a little bit better. In order to make them a little bit more robust, I am going to plate them, right? So I selected them both, and I increased the pad stack. You see here, the X and Y, it was 60 mil, so I made it 160, 160, and I plated the pad stack. So it just creates this area that it'll make the hole more robust, and it'll make it better to be a better mounting hole, right? So we have this done here. This is obviously off the board, so I'm just going to throw it back on. What else? Let's see. In order to show you the capabilities of the copper placement, why don't we add a little track right here? And of course, it's not just placement on the mechanical side, there's also placement on the electrical side. So you wouldn't obviously place something this large, but I just want to show you a functionality that was introduced in Altium Designer 20. So when you define a component courtyard layer, you can see here we have a component courtyard associated with these components, and before you had a bounding box or around a component. You could see here, because we have a component courtyard associated with this component, you can see really here perfect selection of the component. So previously you would get a DRC error for the placement of these two components, right here, but you no longer have this issue. And this will also help with the placement of other components. I have another webinar, Discover 10 Hidden Features. I talk more about that. So take a look at that if you want to learn a little bit more about that. But like I said, that's not very realistic. So why don't we put this one down there? Let's name this C1. And let's do center above. And here's another one of the hidden features I talked about. We now have justification. You see center alignment. So you have perfect text justification for all types of text. So again, if you want to learn more, you can go check out that webinar. I have it up on YouTube, so go check it out. Okay, so we have that placement. That is done. So we come back to the MCAD CoDesigner, and I'm going to say push. C1 added. C1 added. Components moved and plated holes. Okay. I spelled components wrong, but that's okay. We're gonna post and switching back. We see here, it automatically notifies me that changes have been detected. View the changes. It warns me that components with constraints have been moved. So to make sure that the constraints haven't been broken, that there's no issues with that. So I can look at the details, I can click OK. So that's a very powerful thing here to give me a key insight into what has been changed here. So I click OK, or I click apply. Okay, that looks fine. And like I said, I have applied the copper geometry option. So if you click the settings, you can do modeled copper geometry. So it has brought in all of my copper as actual features here. So we look at this design. To make this a little bit easier to view, that's totally in the way. I'm going to change the appearance of this board to glass. So it's kind of see-through. I can click on the copper geometries here. You see this trace here. Now it's clickable. You can see through everything. I can also see that on the ECAD side, I thought I was fixing things. I actually caused a huge error because, again, we are not just designing individual boards, we're designing a product. So I thought I was fixing something and I broke the full product. I moved this key component into the side of the enclosure. So now I'd be able to fix this on the mechanical side, push that information over, and get everything ready to go in a matter of minutes instead of passing things back hours, days. So, you know, I'm not going to go through, you know, fixing this, but just, you know, now you guys understand the concept of it. So we're going to move over back to the last part, which is the question and answers. We're going to initiate the last poll now. I want to thank everyone for their time. If you have any questions,